All right. So your lab number 1 will be due next Tuesday. So just make sure you complete as much as you can. And then after Tuesday, I'll give you a video solution just to walk you through about how you're supposed to build the whole lab from scratch. Okay, that's something I'll show to you maybe after Tuesday. And then we also have a Q&A lab. As usual, we don't have any scheduled tests next Wednesday, so TAs will be there. And then you can definitely go there to ask questions about the lab. I will release some of the guide for your programming test number 1 and also some practice tests as well. Tentatively, we will hold some review session. Not this Friday, maybe the next Friday, maybe in the afternoon. I will keep you posted about the information so you can maybe make some plan for commuting if necessary. All right, I'll reach out to you. Any questions about the course so far? All right, so your programming test 0 will start the grading process very soon. So please give us maybe about a week or so. I'll keep you posted. Hopefully we can get a result released back to you at least before programming test 1. So you can kind of know how you did. But you kind of get a feeling as well, right, from yesterday. So please, catch up if you haven't done so. All right, quick recap from last time. So we do have to go to the new lecture today. We'll see. Okay, so last time we actually dive into how you can use the static variable, especially how you can make ID, for a particular class. Yes.
I actually had a question about programming test 0.
Okay.
So let's say you have 2 students and both students have no compilation errors and fail the exact same tests. But if one student fails those tests because of one particular logical error, but the other student fails each test in a different way, would the grades be the same?
You'll be the same. So in this, according to the guide, so the way we're going to grade the submission is just by how many test cases you're going to pass, right? The test cases will be the one we gave to you as starter, and also some extra ones which are still consistent with the problem description. So we're just going to go with that. I do see where you might coming from. It's fair concern, but just for the grading scheme, that's how we're going to go. We don't really look into the code. But of course, after the result is released, you can either submit a regrading request if you do believe there might be some error, or if you can just drop by my office hour. Maybe potentially we can also maybe have some general feedback, maybe on your submitted code. I think that's the best I can do. But can feel free to drop by. We can talk about it. Okay. All right. So last time we spoke about how you can use the static global counter and together with the non-static ID. So just get used to this pattern here. It might appear possibly maybe another time in your test. Not necessarily programming test, but maybe your exam or maybe a written test, right? So it's very important stuff to see how the mix of the static and non-static variables are going to work. And we talk about different misusages of the static variable. So the first one is really about this counter here, right? So you can see from your lab 0 part 2, we actually use the non-static version. But if you change this non-static into static, you're going to run into trouble, right? Exactly what a trouble is, you can maybe review the notes and also the recording, right? Or if you want me to trace again together with you, drop by my office hour. Another thing I also want to mention, if you haven't got a chance to do so, you really want to do it as soon as you can. So for your lab 0 part 1, on day 1, I mentioned to you there are 2 PDF documents. The first one is about how you can invert Java code from JUnit usages, right? Like a JUnit assertions. And another document is really about how you can study the point and point collector. I think now that you already got good some experience in class and also outside the class about how you can trace the OO code, I think that point and point collector notes are very useful actually for you to go further, right? It does contain some very reasonably sophisticated method that you can actually trace, right? And practice. That's something I want you to try. All right, and then we talk about this particular compilation error, just about using some non-static variable inside a static method, right? So you want to also review about why this will give you a compilation error. And then we got 2 possible fixes right here, right? So we got fix 1 and fix 2. So both will work programmatically. But to see which one actually will make more reality sense, you can also consider, right? That's something we also talk about. Like this one here may not be a good design because branch name may be like an instance-specific value as opposed to something you will share among all the objects, right? Realistically. So that's something you may want to also put some thoughts into. Sometimes things that simply just work programmatically doesn't really mean it will be a good design, right? You want to have a little bit deeper thoughts about it. And then we talk about this example here, just about how we can use this keyword on the right-hand side of the variable assignment, right? So we talk about some general pattern about solving the problem. So let's say you're given the task to implement this particular method, but you're simply not exactly sure how to get started. I would say when you really have no clue how to get started, it's kind of normal, because you're still learning about Java. You may just want to sketch some examples about using this particular method, right? Even before you write any code. So if I say Jim.Mary Elsa, I would know that diagrammatically I should really draw these two objects and think about exactly what the Mary method is going to do. And the critical step, of course, is going to assign the spouse to each other. We know that 1 and 2 are the two steps I should really somehow program into my method. But the issue is I cannot simply write Jim and Elsa because these are just example names. If I simply put Jim and Elsa directly inside the body of the method, it's not going to compile. So I need to somehow identify, in this case, Jim is really the context object. So it should be replaced by this, versus the Elsa right here is really the other, like a parameter, right? So we kind of generalize what's really happening here. So put on the example first, and then try to come up with a general solution. And then we talk about two alternatives about writing this method here. The first one, we say if the proposed marriage somehow should be allowed, then we do something. So what should be the condition where it should be allowed? So we just say that both persons should be single, and we're using the logical operator %, right? So the exercise I want you to try, and we kind of tried it together a bit, is to say rather than having the legal condition here, let's say illegal condition. If the illegal condition here is actually true, then we actually signal some error. Otherwise, we can do the critical steps to construct a marriage, right? So this exercise here, give it a try, and then they do make some logical sense you want to get used to, all right? That's pretty much about what we said last time, and we got two more small topics which you want to really also complete the study on your own. One is about when you have the return type being a reference type, okay? And the other one is about using objects without any name, right? You can also see the slides for detail. And these are all the good stuff you want to maybe start practicing in your labs, okay? All right, any question about the OOP review overall? All good? Okay. So what we should do today is start a new lecture. So including today, we got 5 lectures before the reading week. So I'm hoping that we can at least finish the exceptions. And I do want to talk about some JUnit testing, especially how we can test for exceptions. And then if time permits, we can also start at least a good part about equals method. That would be what we should do before the reading week. After the reading week, we definitely, first of all, we got to finish the equals method, and then my tentative plan is to dive directly into inheritance, which is a very important topic. I want to spend enough time with you guys to make sure you feel comfortable. It's definitely, arguably, the most important topic for the course, nothing else. Okay, but we'll see how that goes. We'll see how the time is going to plan out. All right, so today I want to start with the exceptions lecture. Okay, so the slides are already on the lecture site, and I want to show to you exceptions over here. So today is mainly just about clarifying some terminology, and hopefully at the end, maybe in the final 20 minutes or so, I can also do a little bit of Eclipse just to start, some example from scratch, just to show you. Exceptions here, if you haven't really learned about it before, it could appear a little bit weird at first because it does involve some very patient and careful tracing, especially it's going to involve tracing the method call in different classes. So that's something I want to go a little bit more slowly in the beginning, just make sure you can follow. Okay, but you can slow me down anytime. So today, first of all, we're going to clarify what's really a caller and what is a callee. Every time you have a method call, like a line of method call, you define a caller-callee relation. That's something I'll show to you. Let's clarify that first, because that one will be very useful when we talk about a call stack, when we trace exception. And then console messages, this will be something I'll talk about maybe at the end, just to say if you don't have exceptions, the best you can do is to print out something to the console to say there's an error. But that's not the way to go. Exception is really the way to go, even though it might be a little bit complicated in the beginning. And then arguably the most important principle when you want to learn about exception is something called catch or specify requirements. I'll give you some little bit intuition today, but to really see how that works, we also got to go over some code together. Catch or specify. And for each catch or specify, you also need to know down some new keyword in Java to see how you can program that. And for your lab number 2, which will be released next Tuesday, because your lab 1 is due on Tuesday midnight. So I'll release your lab number 2 maybe on Wednesday, so you can also get a head start. And for lab number 2, it's going to involve exceptions, so you can definitely practice in time. And then this will be some example I want to show to you, just from scratch. Hopefully I can at least get you started with version number 1. Okay, we'll see. There are 3 versions of the example to really go through. And then some additional example, which we'll see. All right. Okay, so let's start with this terminology here, caller versus callee. Okay, let me just switch here. So the most intuitive definition goes like this. They're kind of asymmetric, right? So when you talk about a caller is basically a single method that calls another method. It is a method which calls another method. Okay, I'll put this one into a little bit more elaborate form a little bit later. Calls another method. Symmetrically, a callee is a method that gets called by another method. It is a method that is called by an other method. Okay? So interestingly, the definition here, we say it calls another method. This another method here is basically also the callee, right? When you actually define the caller, you also mention about the callee. Okay? And also, when you define the callee, a method that's called by another method, this another method that calls that method is the caller. All right? So we got caller and callee. They always coexist. Okay? This is the caller. Okay? And it's a very important principle I can also write down right here. Okay? Each method call defines a caller-callee relation. Callee. So this would mean for the same method, maybe in one method call, the method itself is a caller. Maybe another method call context. That particular method becomes a callee. So it really depends which line you're thinking, you're actually looking at. Right, let's look at some example here. So you can see we have a class called C1, and we have a method called M1. Inside the context of M1, we are trying to make a method call, right? This is the only method call we have, o.m2. So this particular line defines like a caller-callee relation. Let's now use this line here to define how we can see, okay? So this particular line here defines a caller-callee relation, okay? So there is a caller-callee relation just by this single line. Okay, let's see what the caller is and what the callee is. The method that's being called is callee. Okay, so what's the method being called? It is this method here, M2, right? You can see M2. However, if you the principle maybe I briefly mentioned, when you're trying to define methods in different classes, methods may have the same name. So when you say M2, you want to also disambiguate to say which class the method comes from, right? So whenever we talk about caller and callee, you also want to talk about class name and also method name. So now in this case, we're calling M2 on this particular context object, right? So just showing you the reasoning process. The O here is the context objects. And then the C2 is the declared type for the context objects, right? So this is the type of your context objects. So this one tells you that M2 over here is a callee. And a callee is a method called M2 that comes from C2, okay? So the way I write it, I can feel free to use other symbol. I just say C2 dot M2. So the callee is a method called M2 that comes from C2, right? It's a M2 that comes from C2, right? It's a very simple reasoning. And of course, don't get me wrong. The dot here doesn't really mean the M2 is static. No, not at all. So you can feel free to use other symbol, right? So this symbol, I wouldn't be picky. That's really just for your reference. So this one does not mean that M2 is static, not at all. All right, so that's about callee. What about caller? Caller is really the context where the method call is initiated. In this case, we're calling this method here under M1, and M1 comes from C1. All right, so M1 C1 will be the caller. So I'm going to just highlight it, right? C1 M1. So this one here is a caller. So this one would be the caller. So the caller we have is the method called M1 that comes from C1. And then just to be complete, and C2, M2 is the callee, right? Caller, callee. Any questions about this? Yes?
Can you go over once more why C2.M2 is a callee?
Of course. So first of all, do we agree? We are calling M2, right? Okay. Because the method that's being called right now is M2, so we know M2 is a callee. But we want to know where M2 comes from. To really see where M2 comes from, you want to see what's the type of the context object. For example, when I say Jim.Mary, the Mary method is being called. But where does the Mary method exist? We want to look at what's the type for Jim. And Jim comes from person, so we know it's person.Mary. Similar here. So O here is a context object, and it's declared as of type C2. So that's why M2 must come from C2. So C2.M2 is the callee. Okay? Yep. It's a very good question here, but guys, you've got to make sure you really understand this kind of reasoning, right? Good. Okay. Very quick exercise for us to think about. That's somehow hinted at in the beginning. For the same method, let's say C1.M1, currently it is a caller. Is it possible that we find another method call or context where the same method may be a callee at the same time? Is it possible? Yeah, sounds quite intuitive, right? Okay, this is almost like a rhetorical question, but I will just show to you. So the point is, every method call is going to define some caller-callee relation. So when you talk about different lines, just different context. So the same method might appear in different contexts, playing different role. That's really the key, all right? Okay, let's just give you one example, okay? So let's see, alternative one, okay? Let's say I want to make C1.M1 at the moment in this particular context, right? C1.M1 is where we initiate the call, it's a caller. But now, can I also create another context to make this method here a callee, right? Make C1.M1 a callee. So the context I'm going to make will be just make a context where we're calling C1.M1. That's it, right? So all I can do is, why don't I create another class called C3? So I can say class C3 here. Okay, let me just use a different color here. So let's say I have a class called C3. And then I'm just going to call C1.M1 in this context. And let's say we got some method, doesn't matter, accessor or mutator. Let me just say void. And then I'll say it's called M. Okay. And I want to call M1. In order to call that, I need to make a context object of type C1. Okay. So I'm going to say C1, some context object O, and then new C1. After that, I can say O.M1. Right, you can see in this particular context over here, O.M1 is a callee because it's being called. Okay. As far as this line is concerned, C1.M1 is a caller. As far as this line is concerned, C1.M1 is a callee. Right? That's really the example I want to show to you. One exercise you can try. Okay. You can try to make C2.M2 over here. Can you make it a caller in another context? Okay, that'll be the exercise for you to try. You don't need to try on Eclipse. This one just sketch something on the paper. That should be sufficient. So exercise, make C2.M2 a caller in another context. All right? All right, any question about caller callee? Okay, it's a very simple definition here, but actually very commonly used. So we're going to talk about chain of method call, and then we're going to talk about call stack. We're going to talk about tracing of exceptions. We'll talk about caller callee always. Okay, so maybe just try to get used to caller callee. Yeah.
For a situation where the caller and the callee are like the same thing, be like recursion,
It's a very good question here. That's good. The answer is yes, okay? I can just talk about it right away. So let's say if I have, let's say, let's say class C, void n. And then, let's say somewhere in the middle, we might just say this dot n. Okay? Let's not worry about whether this is like a correct implementation. I want to illustrate the concept only. But we'll talk about recursion towards the end. Okay? Now, as far as this line is concerned, we know that this line here is being called from C dot n. So that one is the caller. And then we know that this method is being called, and this is really referring to C, right? The current class. So at the same time, we know that C dot m is also the callee. Right? So C dot m is a caller and callee at the same time. And as your fellow student pointed out, this is something called recursion, which we will cover at the end of the course. Okay? But for now, you don't need to worry too much about implementing recursion. You don't need it for any of the labs. Okay? All right, let's now talk about something else. Okay? I want to talk about how you can use a stack to actually trace method call. This is also very important. Okay? Let's take a look. So if you look at the slides, we are now done with slide number 3. So slide number 4, it's something about stack. So I'll let you maybe read off the slides. Actually, that one is pretty straightforward, but I want to do one example to show you all the terminology that you should know. Okay, let's take a look right here. Okay. Let's say we have 3 methods here. We got M1, we got M2, and we got M3. Somewhere in the middle of M1, we're trying to call M2. Somewhere in the middle of M2, we're trying to call M3. And then for M3, we assume that there's no further method call. All right, so that's kind of the setup. It's actually a very typical setup. You might have many methods, maybe in your current lab or future lab, that might call each other in a chain, right? So we just want to show to you how you're supposed to trace them in terms of the execution sequence. And here we talk about a term here called stack. Okay? A stack is so-called a primitive data structure, which you will only learn in detail in the sequel to this course. It's called 2101. You may take it in the winter, but for this course, we don't need to dive too deep into how exactly stack will work. I'll just show you all you need to know about tracing using stack. It's pretty straightforward. Okay? So as far as you're concerned, you're going to draw a stack like this. Okay? It's going to more like open top box, like that. Right? It's a very standard way of drawing a box. Okay? Like a vertical. Right? And then there are 2 operations for a stack. So we say the stack operations, there are 2 of them. Namely, you can add something to a stack, or you can remove something from a stack. So if you simply say add and remove, that would be sufficient for this course, right? However, people who are more into the data structure field, they will call, specifically for stack, it's called push. And for remove, it's called pop. Okay? So push and pop are the terms specifically for the stack. But for this course, you can either say push or add, or you can either say remove or pop. Doesn't really matter, as long as you know what you're saying. Okay? But I might just say add and remove. I just want to make it more intuitive for everybody. And the way you add things into the stack is you're going to add from the bottom. The first item is going to be added here. The next item is going to be stack on top, and then stack on top, and so on. Okay, that's going to be the order of adding things. Okay, so we say that this button here, right here, the very first item that's being added. So this is so-called the bottom of the stack. Bottom of the stack. And then you might have a bunch of things in the middle, and then let's say the very last thing that you added to the stack, right? So this is something called the top of the stack. So far, I have only talked about adding something into the stack. What about removing something? Assuming that the stack is not empty, that means you got at least one item for you to remove. I'm not going to remove from any arbitrary position, like an array, right? You know, for array indexing, you can assign something to any valid index. For the stack, you cannot do that. You can only remove whatever that's on the top, and so on. Once I remove the current top, the next thing here becomes a new top, and you can also remove it. You cannot say, I want to go directly to the bottom and remove it. No, that's not how the stack works. A stack simulates a particular way of sequencing, which will map quite nicely to the runtime execution, which we'll see. Right? So whenever you want to remove stuff from the stack, you always have to go in a certain order. Okay. Also, let me just say one more thing. This will be the first item to be removed. Okay. Let me just show you some direction here. I think it's going to need to be mentioned right now. Okay. So you think about when we go from bottom to top. So this is about the order of additions. So when you add things, you add from the bottom to the top. On the other hand, when you want to remove something, you're going to remove from the top to the bottom. So if you go this way here, it's going to be the order of removal. Okay, completely the opposite. And another important property, or what people talk about, is called the last in, first out property. Okay, it's called the last in, first out. Last in, first out. For stack or level. Okay, how do we understand last in, first out? Let's say I got a bunch of stuff all the way to here. So this is currently the top. Would you agree? This item here must be the very last one I have added to the stack, right? And if I want to remove, which one will be the first one to be removed? This guy here. This item here is the last one that's added in, but this one at the same time will be the first one to be removed from the stack. So that's why it's called last in, first out. So you will see that the later you add it to the stack, the earlier you will be removed from the stack. That's just the way it works. So you got to remember last in, first out. Okay, but we'll see more about how last in, first out is going to be executed. That's something you want to know how to do it. Okay. All right. Let's now try to see how we can trace these three methods all together. Okay. So there is an implicit assumption here. Whenever you want to trace a piece of code, you ought to know where should you get started. It's called the entry point of execution. And for now, let's say if you, maybe when you were doing console application in the system out the print line, maybe back in the first year, the main method would be your entry point of execution. But for now, if you're doing JUnit testing, maybe the very test method that's going to be run by JUnit will be entry point of execution. So it depends. But let's say in this case, we assume this one here, M1, is the entry point of execution. Entry point of execution. So we're going to start the execution from here. We'll say as soon as the execution gets started, the method becomes active. As soon as the method execution becomes active, you're going to put it or add it to the stack. So I'm going to add M1 to the stack right away. Because M1 is now the only method that has become active. It might temporarily become inactive as soon as we have to branch out to some other method call. We'll see. Okay? So let's say currently M1 is active, and also M1 is the top of the stack. Just remember, when we try to trace using a stack, the top of the stack is the method that's being executed right now. That's active. Okay? So the first line, we're going to label. So we're going to use a label 1, 2, 3, 4, 5 all the way just to signal, to indicate about the order of execution for the line. So this one here should be line number 1. Okay? Well, that's going to be the first line that's being executed. And number 2 will be, well, we try to execute M2. So now M2, since it's now being executed, it's now become active. What we do is we're going to actually put M2, okay, M2 over here is now going to become active. Put it to the stack, all right? And it's very important to note right here. When I actually put M2 to be active, what about M1? M1 is no longer the top of the stack. That means M1 will be suspended for execution. When M2 is being executed, M1's execution is suspended. So right now, M2 is the only method that's active. Okay, M2, right here. So now, in terms of the label, right, we got 1 and 2. So where should 3 go? Definitely, 3 should not go here, because we can only get to this line after M2 has been completely terminated. But M2 has not been even executed yet, so we cannot do this line just yet. All right? So think about now we're going to step into M2 in some way. Right? So we're going to actually say M2 over here and M2 right here. So we're going to execute line by line for M2. So number 3 over here, number 4 here, and number 5 here. Right? We reach another method call. That means we have to somehow put M2's execution again into suspension once more, and then come back later. Okay? So what we do is we're going to start executing M3. And we're going to add it to the stack, M3. You can see so far we got 3 methods in the stack, right? M1 was first executed, and then M2, and then M3. All right? So M3 is now going to be executed. Right now, M3 and M3. Okay, just before I step into this method call here, let's review a little bit quickly about caller callee. Okay, let's take a look at maybe this line here first. Now, as far as this line is concerned, so let's not worry about class just yet. So I kind of deliberately omit the detail about the class, just the method. Okay, in this line here, who's the caller? M1, callee, M2. Right? Good. Caller is M1, and callee is M2. Straightforward. How about this line here? Caller and callee. Who's the caller? M2, right? Right here. And then M3 is being called, right? Caller is M2, and callee is M3. And now you can see that again. We just show you again. For M2, in this case, it is callee. But M2 for here is caller, because we're talking about different line. All right, think about all these kind of small issues. Okay, all right, so good. So now number 6, again, number 6 should not be here, because we're gonna execute M3 entirely first. So we get to M3 here, and we're going to put number 6, 7, 8, 9, and 10. All good, because we assume that there's no further method call. After executing 10, we are here. So at this point here, we know that N3's method has been completely executed, is terminated, basically. In that case, N3 should be removed from the stack. So N3 finishes its execution. We can just say it terminates. In that case, it should be removed from the stack. All right, remove it. Once we have removed M3, you can see now the top of the stack becomes M2. That means M2 has now been put from suspension back to being active. So we should really actually try to resume the execution of M2. But we don't really start from the beginning anymore. We should start from where we left off, which is over here. So if you are currently studying, well, maybe next term, like a 2021 computer organization, you may have learned about some concept called program counter. You might encounter the concept very soon. Program counter is really the behind-the-scene mechanism to tell you where to resume the method execution whenever it got suspended, right? But for now, you don't need to worry about program counter. Just remember, if I say I want to go back to M2, you just got to remember, because previously I suspend M2's execution right from here because of M3. So now I should really continue in here. So now I should really get 11 right here, right? 11 and then 12. And at this point, I'm done with M2 execution, right? So think about at this point here, N2 terminates. In that way, I'm going to remove M2. And now the top of the stack becomes M1, so we should resume M1's execution. M1's execution was suspended right at this point, so we resume from here. So now we're going to put, after 12, we got 13, 14, and 15, right? So similar idea. At this point, we know that M1 terminates. M1 terminates. And then remove M1. And now the stack has become empty. That means we're totally done for the entire thing. Right? So this kind of a way of tracing the using a stack is actually very fundamental, especially at this point. Especially later on, we're going to see how the exception is going to work. You do need this kind of a concept, okay, about stack. All right? Any question about this? Okay. Okay. Let me make some quick remark right here. So what we have is we have this stack right here. So we got M1, we got M2, and also we got M3. All right? M1, M2, M3. And M1 was really called to execute the earliest. To execute the earliest. And M3 over here is started executing the latest, right? Because you look at here, M1 was first starting here. M2 only starts at 2. M3 only starts at 5. If you look at the number there, right, you do see the sequence, okay? So M3 over here was called to execute the latest, okay? So we say that if you look at the order again, from M1, N2, N3, right? It's more about timing. It's so-called a chronological order. Chronological simply means timing, okay? It's called a chronological order of method call. Chronological order of method call. Okay, that's this way. And one more thing, reverse order. If you actually talk about, let's say in this way, the green one. If you go from M3, M2, M1, and that one there, I'm going to write it here, it's the chronological order of method terminating. Chronological order of methods terminating. All right, any questions? So go ahead.
Can we have two stacks or multiple stacks at the same time running? For example, we have two M1s, and then wait,
Yeah, actually, you don't. Well, since here we don't talk about anything. Well, we only got one thread or only one sequence of execution. We don't have anything called concurrency, so we don't have to trace using two stack. So as far as tracing is concerned, you always use a single stack. You just have to know where the entry point of execution start from and go from there until you get back to the empty stack. Yes?
So then we have two threads, if we multi-thread, then we have access to that.
It's possible. So sometimes, if you got one, of course, that's beyond the scope for this course. You might learn a little bit more in the operating system course. So if you really got multiple threads that you have to somehow synchronize together, you have to know what's the states, what status for individual thread. In that case, for individual one, you may want to use a stack to know where you are. Yes, it's possible. Right, that's a little bit kind of beyond the scope. Yeah. Yeah, once you get to multi-threading, of course, it's way more complicated. Yeah. All right, good. So guys, as far as this course is concerned, just know how to manipulate one single stack. So we are still going to use a stack to really talk about exceptions, but I think I'm going to come back here again for more complicated tracing when we talk about recursive method. That's something also going to be useful for us to see, but later. All right. Okay, I would suggest that we go for another 10 minutes and then we'll do a break. Okay, just give me 10 minutes. Okay, I want to talk one thing very quickly. So we are now done with the caller calling, and also we are now done with the call stack and method call chain. So in the next 10 minutes, I want to talk about something called the catch will specify requirement for exception. I want to talk some conceptual stuff on the paper, and then we do some coding a little bit for today. Okay, we'll see. Okay, hopefully 10 minutes. So here we got a stack of method call. So where's the stack, right? You can think about implicitly there is a stack right here. So this is the stack that we can imagine, okay? That's the stack that we talk about, right? So there are 3 method calls. So we have the main method. That's the entry point of execution, okay? So let me just annotate it. So the main method here is the entry point of execution. Entry point of execution. So the main method calls another one, this method calls another one, and this method calls another one. And somehow the stack will stop growing from this point because some exception occur. I'll talk about it, right? But let's just annotate something that we already know. So let's say this method here is called M1. Okay, just give it a name. This is a method called M1. This is a method called M2. And this is a method called M3. Okay, so we have 3 caller-callee relation, basically. Right? You can see we got 3 arrows over here going this way, right? You remember we're going this way. It's about the chronological order of method call, right? We just said it in the earlier page. So the first one, we have the main method calling M1. In this case, the caller is the main. And the callee is M1, right? And then for this one here, the second method call, we have M1 calling M2. So the caller is M1, the callee is M2, right? Again, the final one, we have right here, right? The final arrow. So we have M2 calling M3. So caller is M2 and callee is M3. So we got 1, 2, and 3, caller-callee relation. Okay. In theory, the stack can grow as tall as you like. In this case, we say that the stack is not going to grow any taller because when we reach this point here, some error occur. In our case, some exception got thrown. Okay? We'll learn about how exactly you can throw some objects of type exception. We'll see that, if not today, definitely on next Tuesday. So here, the error we're talking about is some exception. You can think about exception in Java is kind of like a special object. As soon as the object is being created, you must actually handle that right away. You cannot really wait or delay. Okay? And that's one thing very important to show here. As soon as an exception is thrown, exception objects is thrown, the call stack stop growing. Stops growing. Okay? This is a very important principle. Because you might be wondering, is it possible that even though we got some exceptions thrown from here, but there might be another method called stack on top? No, not possible. As soon as as soon as an exception occur, you got to handle that right away. All right. Now, we want to understand something that's called catch or specify principle or requirements. Yeah. One moment. So this is something called catch or specify requirements. Go ahead.
The exception handler be in the top method, so it can continue growing after the exception happens. So, for example, a problem happens, it fixes the catch exception, then continues.
But before that, you gotta make sure at this point we gotta do something, right? So at this point you cannot grow any further. But afterwards we don't know. That's why we don't want to show. At this point you cannot grow any further. We talk about right at the point the exception is thrown, right? Okay. So the catch will specify requirements. So thinking this way. So now starting from this point here, right? You can think about almost every method that's involved in the call stack. I say almost, because there will be some rule you have to follow. Let's say, just for now, just say every method. Every method that's kind of involved in the call stack right here, each one of them has two choices to really handle the exception. Either they can specify the exception. The analogy would be exception is more like a problem, right? So now I'm facing the problem. I got two choices. Either I can throw the problem to my caller. For example, this method here can throw the exception back to its caller and let the caller handle. So I don't want to take the responsibility. That's choice number one, like specify. On the other hand, the catch option here is saying I'm facing the problem and I want to solve it right away on the spot so that my caller and anyone down the line in the call stack, they don't have to worry about this problem anymore. Right? So I basically got two choices. So what would be some very extreme and very bad scenario? I can tell you right away. Let's say this method here got the exception. It specified it, doesn't want to handle. This method here also specify it, doesn't want to handle. This method here also specify it. And this method here also specify it. What does that mean? That means the exception is thrown directly to the console, to the clients or the user of your program. So this will be the no-no situation you want to avoid. But I'm going to show to you also later how you can run into this kind of extreme scenario. You will hope that at some point, at least one method will choose to catch it at some point. Okay? At which point, it depends on your design. Okay? But in the lab number 2 and the other labs onwards, or in the programming test, we will actually set up the JUnit test in a way that you will know where to really catch the exception. Okay, let's now talk about the principle, right? So there are several bullet points I want to talk about. So when we talk about catch with specify, okay, principle is 0. Okay, so 0 over here. Where the exception is originated, in this case M3. We normally just do specify. We don't really try to handle that right away, typically. Okay? Where the exception is originated, specify it. It's like a special case. So you can think about, so here, 0, and 3, where the exception is thrown, only specify it. Specify. Okay? So that means M3 is simply going to throw that exception back to its caller. Okay? So this is principle 0. Okay? So 0 here, and 0 here. That is what this arrow really means. Okay? For all the callers onwards, they do have the freedom of either catching it or specify it. Let's see. Okay, two different scenarios. Let's say now M2. M2 is now facing the exception problem. You got choices. Either you can specify the exception so it throws that problem to its caller, which is M1. Or M2 can say, I want to catch it right away. But in this case, the diagram shows that M2 is simply going to throw that exception to its caller further. So that's why we say propagates or forwards. It's going to propagate or forward the problem to its caller. Okay? So here. So we say 1A. So 1A, method may specify the exception which is propagated to its caller. So the example we're given is, let's say for M2 is the method that we're talking about. And M2 is simply just propagates the solution to M1, its caller. Okay? So just to let you know exactly where the caller and where the callee is, right? M2 to M1. Okay? Let's now take a look at this one here. So we got M2 simply throws the exception, well, propagates the exception or specify the exception to its caller. So this will be 1A. So 1A, M2 also specifies. Okay? Like that. Okay? Like here. All right, the final one, let's say we're here. M1. Two choices. Either M1 can choose to propagate it further to its caller, which is main. But in this example here, we choose to catch it. Okay? We want to fix that problem right away and solve that on the spot. Okay? So this will be 1B. So 1B, here, a method may catch the exception. And pay more attention to 1B over here. Once the exception is already caught at this level, any further caller is not going to need to specify or catch anymore. Beyond this method, all subsequent caller not subject to the catch or specify requirements anymore. Okay, that's very important. And so the method that we're talking about right now is M1. And when I say all the subsequent callers, in this case, only the main method, right? That's kind of down, right? Kind of below M1, all the subsequent caller, which is the main. Okay, let's now take a look at this one here. So really talking about M1, simply try to catch the exception, right? You can see the error only goes back to itself. It doesn't really get propagated to main, just right here. Hello? I'm not going to warn a second time. Okay? Is that understood? Oh yeah? Yes or no? No, not you. Him. No, you. Laptop is only for taking notes. Yeah. If you try to do it again, I'm going to ask you to leave. Is that understood?
Yeah, I'm using it for notes.
Yes or no? I don't want to debate. Do you understand what I'm saying here?
Yeah.
Yes, right? Okay. Okay, so now, for this one here, we are basically got 1B. So we got M1 catches. So that means the main method is not subject to catch or specify requirements anymore. All right, so that's the 1B. Okay, so let's now draw a line right here. Okay, you can think about beyond M1. No more catch or specify requirements beyond this point. Beyond this point, no more. Okay, when I say no more, I just mean no more catch or specify, right? Just got running out of space. So just watch out over here. So this is only the first time we are talking about this principle here. So the catch or specify is really something that every level has to obey. But once you actually do the catch, any subsequent caller is not going to do trial catch anymore. That's something we'll see once we get a coding. Just to remember this principle and also revisit this diagram. Yeah, go ahead.
So when a method like catches an exception, what happens to the other ones that are like they're like supposed to happen after?
Okay, how about this? I think that this diagram here, just to kind of show to you about the sequence of catch or specify, somehow to see roughly how it goes, I would suggest maybe wait until we see the different versions about the method, and then we'll see. Okay, just bear with me. Okay, I think this one is not supposed to cover everything you should know about exception, just to give you some general idea. All right? All right, guys, why don't we take a very short break by taking attendance. After that, we'll do a little bit coding. Okay? All right, so we got 20 minutes exactly. So I would suggest we try to do some coding in Eclipse from scratch, okay? I'm gonna show to you about the option that I was talking about, okay? Let me just talk about the setup for the classes right here, okay? And then we'll go on. So there are 3 versions in total. I'm hoping to at least develop the main part for version 1. And then there will be quite a bit of a tracing we have to do as well, which I'll try to see how much I can do. We'll see. We got 20 minutes. So I'm going to have 3 classes in total. So we got class A and class B, and also we got tester. Okay, so we got these 3 classes. And we can first of all figure out exactly the caller and callee, and before we dive into the code. Okay, so let's say in class A, we have a method called MA, and it's going to take some integer parameter. Okay, and then we say that if the parameter is less than 0, it's going to be some error. And we're going to show you exactly how to program the error by throwing some exception. So there will be some syntax you will have to pick up from this example here. If the value here is not less than 0, it's not an error, we can do something, right? So you can think about MA over here is the method that might throw some exception. It doesn't really throw the exception all the time. It only throw the exception when I is negative, all right? Watch out here. And then we have class B here. B here, we are trying to call MA, right? You can see MA comes from class A. So this caller-callee relation is going to define MA is a callee, which comes from here. And then B here is a caller, right? So you can think about right here. So when we are in class A, we don't really have caller-callee. There's no method call, not applicable. But when we get to class B, right here, we have the caller will be B dot MB. B dot MB, and then the callee will be A dot MA, right? A dot MA. And then we also have another class over here, tester. And we have the entry point of execution called main. Okay? So inside the main method, we're actually trying to call MB. So MB is not the callee. Who is the caller? Tester.main, right? This is where the method call is initiated. Okay? So we have right here, okay? So B.MB is being called. So B.MB, so now we in C, right? And then, oh, sorry, not C, beg your pardon. It's the tester.main. So now we are in the tester class. And tester.main. Right, and then you can also think about what's going to be the look for the call stack. The entry point of execution is going to be from here, tester.main. We'll start from here. So we start from tester.main, and which we'll call MB. MB is called right here, so we count it here. So B.MB is being called. And inside its context, we also call MA, and we go to here. So that means A.MA is right here. And if you somehow recall the stack that we spoke about earlier, when you got, in general, some stack of method call, when you get to the top right here, let's say A.MA, if some exception occur right here, you have to handle it right away. No further method call should be allowed until you actually handle that, right? So that's something we'll see, right? So we got a stack of method call right here, 1, 2, and 3. And we're going to look at like a different possibility. From here, the exception is going to be thrown, and we only specify it. We just follow the rule. Okay, that's a convention. So now when we get to B.MB, it has 2 options. Either it can specify it, or it can catch it. And also, if we ever get to tester.main, it also got 2 options, either to specify it or to catch it. Right? So these are the different combinations. So we're going to see version 1, version 2, and version 3. Right? I'm going to show you different versions. Let's just go to version 1 and see how it will work. Okay? And we'll do some tracing as well together. Okay, okay, so we go to Eclipse. Let's say we go to create a already created a new project. And this source code I'm going to demonstrate is also on the lecture side, right? So I'm just going to reproduce it, maybe with some additional lines. So what I'll do, first of all, I'll create, let's say create different packages for different versions. So let me say I got version 1. So right click on the source, and then I'll say new package, version 1. All right, so I'm going to put version 1 here. And then I'll start with A. So new class A. All right, right here. All right. So in class A, we only, let's say we don't have a default, we have default constructor. We don't need to declare that, right? We just focus on the method MA. So I can just say that. How about this? Public A, and then like that. Just a constructor doing nothing. And let's say there's no attributes. Make it even simpler. And I would say void. The void method, also MA, integer I. Okay, right here. And I'm now going to specify the condition. If I is less than 0, I'm going to do some error. Okay. So what I will do is I'm going to say if I is strictly less than 0, there's going to be some error. I'll just say error for now. Okay, I'm going to show you the syntax. Otherwise, do something. Okay, system.out.println. It's not a good practice, but just for illustration. I'm just going to say system.out.println. Okay, so here you can say I is larger than or equal to 0 from a.ma. Question?
On the slides, shouldn't the method code have throws the exception?
I'm getting there. I'm getting there. Not yet. Yeah. Now I just want to show you the skeleton about how things should be understood, and then I'll introduce the syntax. Right? Since your fellow student haven't learned about the syntax, it's better not to throw that to them right away. Right? All right. So now let's now talk about how we can specify the error. Right? So now for the error, right here. So this will be something you will have to learn. Okay. So the syntax is something called throw, like a verb. Okay. Throw. And then here we're going to use something called anonymous object, which we kind of did in the review slides, right? I'm going to show to you. Okay. So here I'm going to say throw new and some exception. Okay. So in this course, we'll allow you to create exception that's kind of customized with certain name. We don't just need to say throw new exception. That's a little bit too general, because depending on what kind of error we have, we might want to give different name for the exception objects or different type, right? For your lab number 2, you're going to see exactly this kind of customization, like about the different names you can expect, right? Let's say for now, we want to throw new some negative value exception, right? Let's say negative value exception. Okay, and then so this will be calling the constructor from the negative value exception class, which we haven't created just yet, but we will. We can use some auto-gen feature from Eclipse to help us with that. Okay, and here you can actually put some messages over here if you want to. You can just say a little bit more about, for example, what's the value of I. Okay, you can say I is equal to, for example, plus the value of I. Okay, like that. So, of course, it's expected we got some compilation error, right? If you move your mouse over the negative value exception here. Yeah, so let's see here. If you move your mouse over, okay. So it shows like a negative value exception cannot be resolved to be a type. You may have seen this before, right? If you declare something or using some constructor, but it doesn't exist, it cannot be resolved. So what should we do? We should create that one there, okay? So for this one here, I don't quite recommend you try to create that manually, because there will be some details you have to make sure you add, and that's to do with the inheritance. Because anytime you want to create some exception type, you have to make sure it kind of extends the exception class, which I don't really want you to get confused at this point. So all you got to do is move your mouse over this negative value exception here, because this name follows right after throw new. So Eclipse will know you actually want to create some exception class. Okay. So move your mouse over, and then you will see that there will be some suggestive fixed. One of them, usually the top one, create class negative value exception. Click on that, all right? And then you will see that right here, there is some field here called superclass. If you only create a class from scratch manually, you will have to fill this out yourself. But if you do the auto-gen, you don't need to. But Eclipse will do for you. And we wouldn't talk about things like a superclass until after the reading week. So for now, I don't want you to worry about it. Just use the auto-gen. That will be good enough, right? You can double check everything, make sure it's in the right package and also the right name, right? It's called negative value exception and say finish. Okay, so that's a class that's being generated right here. And then if you go back to class A right here, it's still complaining. It's mainly complaining about we are letting the constructor take some string, but the string is not there just yet. Okay, that's version of constructor. So we're just going to define that. So I would say this might be the only part you have to somehow remember or memorize. Very small part, right? But you're going to practice that for many times when you're doing lab number 2. So when you get to programming test number 2, so that shouldn't be an issue anymore. Okay. So what we're going to do is define some constructor that will take a string. So public, the name of the class should be the constructor name. And then you have string s. All right, like that. And then here, you got to write a line, okay, called super s. Okay. Now, super here is also a keyword that we only cover when we talk about inheritance after the reading week. For now, just take it for granted. So what we're doing here is we are creating a constructor in the exception class we have created. And that constructor can take some string message for you to get more meaningful message at the runtime.
Actually, you don't need to memorize anything. You can just write it and create an exception. It fills the information with super and everything.
No, here, I'm just saying this version here, we just want to create that version of constructor that will take some message, right? But if you want to do something other than this, just make sure you know what you're doing, right? Yeah.
If you want this to be filled out, you can just create an exception. Instead of a class, you take an exception and fill it out for you.
Sure. I mean, there might be other ways to generate it. I'm just saying this might be the quickest way, right? Because you can move your mouse over that error line, and then it will just create for you. Sure. All right. So that might be the only part you wouldn't understand 100%. But I think that's okay to tolerate at this point. So we got the exception class, and also we got A, right? MA. Let's go back to A here. So now we got another issue, all right? You can see the same line actually gave us so many issues. I got to fix one by one. Now this kind of issue has to do with the catch with specified requirements. Let's see. I'll move my mouse over, and then I'm going to read it to you. Unhandled exception type, negative value exception. It is saying that in the context of this method here called MA, we are seeing some exception called negative value exception. It might be thrown, but we are not either specifying it or catching it. As soon as the exception occurs, it is subject to catch with specified requirements. But now we are neither specifying it nor catching it. So we've got to choose one of them. So remember principle 0. Okay, let me just show you again. Principle 0 is right here, where the exception is originated, in this case, MA. We're just going to specify it. We're just going to throw the problem to the caller of MA, which is going to be in class B. That's all we do. Okay, we are following the principle just for 0. All right. So what we do is go back to Eclipse to really specify an exception. Another syntax you got to learn. Okay, you can see typically you will just finish the parameter list by some closing parentheses, right? And then to start the body of the method, you say some opening curly brackets. Now in between, right here, you're going to type a keyword here. Okay, it's called throws rather than throw. Throw simply means this method here, when you call that, you can expect the exception to be thrown sometimes, not all the time, sometimes. Right? So throws the name of the exception. All right, so now everything compiles. Okay, so what we have done is this. This is the place where the exception is thrown or originated. And from this point onwards, every method that's involved in the call stack is going to be subject to the catch with specified requirements. In this case, in the very first place where it's originated, we're going to say throws. Okay, right here. All right, any questions so far? Yes?
Can you explain those negative value exception again?
You mean this one here?
Yeah.
So you can think about, okay, first of all, just for this part here, it's more like a header of the method. It's kind of telling about any potential user of this class to say, if you want to call MA, You know that the return type is void, and also the parameter is I. That's what you know. And now we are extending the header by saying throws negative value exception. So that would mean any potential user, if they want to call this method, we're telling them not only that the method returns void, takes some integer, but it may throw some exception called negative value exception. That would mean when you call this method here, you got to watch out because it will be subject to the catch with specified requirements. For example, the next class we're going to create called b.mb is going to call this one. Here, we're going to see, okay? Yeah. Okay, about 5 minutes, right? We should be able to do also b. And then that'll be a nice pause. All right, so now let's create another class. New class, let's call that b. So b now is going to be a caller, okay? So I would say, first of all, let's create a constructor. Public b, okay, just doing nothing. And then we'll say public mb. Also, it might take some integer I. All right. So now, the body of this method here is very simple. It tries to call the method a.ma. So create some context objects. So a, object a, new a, right? And then oa.ma. Whatever I that's passed to mb, we're just going to pass that to ma. Thank you. I appreciate that. I agree. Absolutely. All right. Now we have a compilation error. Let's read it. If you move your mouse over here, let's see what it says. Unhandle exception type, negative value exception. Okay, anybody kind of see what's going on here?
The function we're calling throws an exception that we're not dealing with.
We are not dealing with it, right? Catch was specified, right? So now caller is b.mb. The callee is a.ma. ma, as part of its header, says it may throw the negative value exception. So that means for you as a caller in b.mb, you must either catch or specify. Okay? Let me show you the catch option. Okay? To really catch it, okay, you can actually do the following. Okay? So you got to do something called a try and catch block. So this will be another syntax you got to learn. So any method that you actually want to any method call that might throw some exception and you're kind of subject to the catch with specified requirements, you want to put that method call inside the try block. So the try block may contain multiple lines of code. You may get multiple lines that might throw certain exceptions. So there might be multiple exceptions being thrown. But in this case, just one. Okay? What about the catch block? The catch block here can be multiple, right? You may say catch here, you may say another catch, you may say another catch. As many catches as you like, depending on how many exceptions that might be thrown from here. Let me just finish this part and then I'll take a question, okay? So let's say we only got one here, because we know that this line here may throw negative value exception. So what we'll do is we're gonna say catch here, and then put negative value exception here. Right? That's the name of the exception here. And then we have, it's this part here is more like declaring a parameter for this catch block. So you just say negative value exception, and we want to have a way to refer to it. So just say negative value exception. Doesn't matter. You can choose whatever name you like. It's more like a parameter. You can choose X, choose Y, right? Okay. And then like this. Okay. So this, if you can ever reach this block, that means the exception is caught. You might do something else. Question.
So you mentioned that you could choose to specify instead of catching. What would be the benefits of specifying instead of catching?
Think about the consequence first. Let's now worry about which one might be better. Okay. So now you can see that here, MB, we choose to catch it. Right? So I'm going to show you maybe next Tuesday. Okay. Once MB catches that, that means the caller of MB, if you remember the call stack, test.main. When test.main call MB, it's not going to worry about this exception anymore. Because MB, as part of its header, has no throws negative value exception. That's the consequence. On the other hand, if MB over here, we choose to specify it. Let's say MB, as part of its header, say throws negative value exception. When tested on main calls MB, it is still subject to the catch with specified requirements. So it's really no hard rule about which one should really go for. It's more like a balance you want to choose. Bottom line, you shouldn't say every caller in the stack choose to specify it, which I'll show to you. In that case, any exception happening will just be thrown to the console, which is unacceptable. How should the user deal with it, right? Okay. So guys, I'll pause over here. So make sure to review everything we said today. It's very crucial. And then we'll continue with version 1, finish it, and do the other 2 versions.